7.4 goes into annuities. An annuity is a sum of money paid as a series of regular payments. I think it's easier to explain through an example. Let's say I wanted to buy a car. I can't very well pay for a car right now. I don't really have the money for it, but maybe I'll have the money in the future if I just make regular payments towards it. Now I think if I take a look at my paycheck every month, I could probably give up $100 every time. Hopefully if I take that $100 and I invest it, I'll gain some interest every single time, and then I could probably afford the car in the future after sum totaling all of these payments. So let's take a look at a timeline just to solidify that idea. R stands for your payments. Now I said that I could probably afford $100 every single month. So each of these R's stands for $100. Okay, now I also said that I was going to pay every month, and let's just pretend that we're going to do this for 5 years. I'm going to invest this $100 every single month into a bank, and I'm going to earn some interest. And since I'm doing it 12 times a year for 5 years, my N is going to be 60. Okay, now I want you to understand that this very last $100 payment is going to come at the end of the last compounding period, so it's not going to gain any interest. However, that first $100 that you invested was invested such a long time ago that it's going to be gaining the interest to the power of 60 minus 1, which is 59. It's going to be gaining a lot of interest because it's been in the bank longer. All of these numbers eventually will be added together to create that annuity. It's actually a geometric series, so take a look. If your first term is your R, your first payment, $100, and it looks like each and every time you're going to be gaining some interest, so the 1 represents 100% of the R, and then the I represents whatever the interest is on the R. So you're doing R plus the interest. We're going to sum that up in the geometric series formula. So you put your R into your A, or I guess your big R. Your little r is going to be 1 plus I, and it's down here as well. And then if I simplify a little bit, the 1's disappear. 1 minus 1 gives you 0, so I only have the I on the bottom. This is your new formula for the annuities. Okay, so if you want the total amount of an annuity, you're going to take your payments, your regular payments, and then you're going to multiply 1 plus your interest rate affected by your compounding period, and then your time, which is also affected by the compounding period, subtract 1 all over your I. Number 1. At the end of every month, Zainab deposits $200 in an account that pays 4% per year, compounded monthly. She does this for 3 years, so she's probably saving up for something big. A. Draw a timeline to represent this annuity. What we're going to do is we're going to start off with now, and we're going to write down the fact that she puts in $200 every single time. Okay, now how many times does she do this? If she's going to be doing this monthly for 3 years, then that means she's going to be investing 36 times. Now you don't have to draw all 36 ticks. I mean, some at the beginning and some at the end kind of gives a person a sense of what the timeline actually looks like. But you do want to include all of these, and that's just telling you how much each of the investments is going to be worth. So the very last one will have no interest on it, but then the very first one is the one that will have the most interest because it has the longest amount of time to invest or to grow. Okay, now where did I get this number from? I took the 4%, and remember that you're getting the 4% for the entire year, and we want to know how much she's getting every month, so we're going to have to divide by 12. Okay, so B is asking you to determine the amount that she's going to have after 3 years. If we put everything into the annuity equation, we're going to get our initial value, which was $200 for our payment, 1 plus your I to the power of your N minus 1 all over I. Do some BEDMAS, brackets first, then exponents, subtract 1, get this one, and then multiplication and finally division. And it looks like she gets $7,636.31. Now the last question, what did that ask you for again? How much interest will the annuity have earned? So let's think about it logically. If she had just taken the money and put it under her pillow, she didn't invest it, she's going to put $200 every single month for 3 years under her pillow. So she's not going to get any interest. We're going to take $200 times your 36, and you get $7,200. But if she had invested in the bank, she's going to get this much. So really, the amount of interest would be a simple subtraction. Remember, we denote that with a big I because it's a dollar amount. This one subtracted by this one, and it looks like investing in the bank would have been a good idea because she gets $436.31 extra as interest. Number 2, Catherine is trying to plan for the future. She needs $5,000 for university tuition when she graduates in 2 years. She plans to make deposits into an account that earns 5.5% per year, compounded weekly. First of all, let's take a look at what a timeline would look like. We don't know exactly how much she's depositing each time, but they are the same amounts every single time. Now, how many times is she going to deposit? Well, if she's doing this every week, so that's 52 times a year, for 2 years, we're going to double the 52 and get 104 deposits. You also want to indicate the interest rate and how much each of the deposits should be. So you have the interest rate, which is 5.5%, but remember that's for the entire year. So we want to know how much she's going to get weekly, and that's why we divide it by 52. So that was about 0.0011%. Okay. Now we put everything into the formula because obviously they're going to ask us to calculate the deposits. We know that we want a future value of $5,000. We have our interest rate and the N. Okay, so what we're going to do is let's bring this guy over to the other side first. Okay, then we multiply these two and I get about 5.29. I could also figure out what all of this is. So this to the power of 104 minus 1, I'm going to get 0.1162. Now if I want r by itself, I'm probably going to have to divide this out because these two are multiplying. So I divide it out on both sides and I get r as 45.51. That means that she must deposit 45.51 every single time. Here's the last question. I just bought a new house. So Mrs. Nguyen just bought a new house. She pays $1,325 monthly towards her mortgage. Her financial advisor informs her that she will be able to pay off her $435,000 mortgage in 20 years. What annual rate of interest compounded monthly is Mrs. Nguyen's loan earning? So what exactly were we given? It looks like I'm making regular payments of about $1,325. That's my R. Eventually, I'll be able to sum total all of those and it should pay off this humongous mortgage right there. I want to do this for 20 years and then 12 times a year. So my N should be both of those multiplied together, which is 240. Now I'm going to sub everything into my equation and it looks like I'm looking for I. Now remember, it's really difficult to actually look for I. You can use your graphing calculator using the intersection method or the TVM solver and calculate I. So again, we went over this in class before, so I'm not going to go over it in this video. But if you have any questions, you can always ask. Okay, so going through the graphing calculator, either way, it gives you an interest rate of about 3%. Okay, so we're just going to add a therefore sentence. The annual interest rate is 3%.